Hey guys, my name is Natalie Villafranca and I'm going to be talking about TLC. So first of all, what is TLC? TLC stands for thin layer chromatography, and the thin layer stands for a thin layer of silica, and the chromatography stands for chromatography. TLC is often used as an analytical tool to help understand different compounds by identifying them and determining their purity. So if you're given unknowns, you can determine which compound that is based off of your TLC results. TLC has two phases, a stationary phase and a mobile phase. So the stationary phase is the actual TLC plate itself. It's either made up of silica gel or alumina coated on a glass, metal, or plastic film. So when you see the TLC, it's actually hard, unlike a paper chromatography experiment. So when I first saw it, I thought it was paper chromatography, but it's not. So next, how do you do TLC? So first you have to make sure that all of your samples are dissolved in liquid form. Then you prepare your TLC chamber and plate. A TLC chamber is really just a 500 ml beaker with a piece of filter paper surrounding the inside, like in this photo here. The filter paper helps keep the chamber saturated and prevents the vapors from evaporating. Then you would add some prepared solvent and then make sure you get the filter paper a little wet. And then once that's prepared, you use a TLC plate and you would make sure to not touch the TLC plate directly, like on the white part, because your oil can mess it up. Similar to chromatography that you do like in GenBio, you would, on the bottom of it, like here, about a centimeter from the bottom, and then you would do a mark, and then on the top you would do the same, about 3 centimeters from the top. And then you would mark a spot at each spot where you would want to do a sample. Then using a capillary tube, you would get some of your sample and then place it on one of those spots that you created with the pencil. Make sure you rinse your spotter with acetone in between samples. And then you place that into your TLC chamber that allow the thin layer chromatography to develop. So depending on the solvent mixture / mobile phase that you're using, it can take 2 minutes all the way up to 40 minutes. If you're using something really polar, so it has a lot of ethanol or a lot of water, it can take a really long time, so 30 to 40 minutes. And if your sample is very non-polar, it can be 2 to 5 minutes, so it'll move up really quickly. Once you're done, you need to immediately mark the solvent line with pencil so that you know how far up it traveled. If your sample isn't colored, you'll have to use a UV lamp or a chemical dip that'll produce a color change. Once you mark these spots, you can measure the RF. The RF is equal to the distance traveled by the substance divided by the distance traveled by the distance traveled by the solvent. If you're given unknowns and you are able to calculate their RFs, that means you're able to identify which unknown you've been given. So what's actually happening molecularly is really cool. So the silica gel is really polar and capable of hydrogen bonding. So as the solvent travels up the plate over the spot of the sample, an equilibrium occurs, causing the development solvent to compete with the silica for the mobile solvent. The development solvent moves up the plate via capillary action, while the mobile solvent, which is the sample that you're testing, will depend on its polarity. So the more polar mobile solvent sticks to the silica a lot more tightly, and the less polar mobile solvent will move more freely. So your polar solvents won't travel as far. As I said earlier, like it can take up to 40 minutes, but your non-polar ones can actually travel a lot quicker because it's like a like dissolves like kind of thing. So that was my presentation on thin layer chromatography. I hope you enjoyed.